Okay, before we get in and start configuring our RDS, let's talk a little bit about failover. Because you've already seen how we configure an RDS instance. We're still going to go through the wizard, but I want to highlight the failover capabilities so that you're kind of getting a different perspective from a system administrator, system operator's perspective. So you have multiple or multi-availability zone failover. What that means is in an RDS deployment, when you're deploying it multi-availability zone, it's designed for HA. Now, the way that it's designed for HA is that it has synchronous replication to a secondary availability zone. So what happens is it's a master-slave type relationship. You have the master, which is the database that you're going to be doing your reads and writes to. That's going to be in one availability zone. It is going to synchronously replicate. So every time there is a write, that write is going to happen in two places at the same time. However, the standby or the slave database is going to be in a completely different availability zone. This will give you the highest level of availability because in the event that the master should fail, because it is synchronously being replicated, AWS will automatically switch over that DNS name to that standby, to that slave, and it will continue to accept your writes and the functionality of the database continues. And once that master is restored, then it switches back and so on and so forth. So you have that synchronous replica. Now, the advantage of having that standby, first of all, that standby is invisible to you. So you don't see it, you can't touch it, you can't manipulate it. Again, it's all part of that platform as a service that they are offering you. But it is there, and it is there for a number of reasons. So for example, the standby replica is invisible, of course, but it also allows you to do certain functions against it. So for example, any type of database snapshots are always taken against the standby instance. Now you're probably asking, well, why? Well, when you're taking a snapshot or when you're doing backup or when you're doing any kind of an update, you kind of need to lock that instance for maybe seconds, but even those seconds will generate latency and that will reflect against the users right away. Because you're synchronously writing to the master and to the standby at the same time, instead of affecting the master, hogging it down with snapshots, with backups, with updates, whatever, you do that against the standby. Now, what happens is once you do it against the standby, then you can make that standby the master, update the master, and then flip over again. I'm going to show you this in an animation and it'll be clearer. But again, the idea here is that all maintenance tasks happen against that standby. AWS will automatically adjust the DNS record when needed, exactly for the purposes of failing over between them for maintenance reasons. Now, multiple availability zone is different from an RDS read replica. We're going to cover read replica in a second here, but I just wanted to make sure I highlight the fact that with a failover, with multi-availability zone here, you have that master standby relationship. The standby is invisible to you. You can't manipulate it, whereas a read replica you could. And read replicas are designed to help offload the read operations that are generated from a database. But they have different characteristics, and we'll take a look at them. But before we do that, let's take a look at how it would work in a multi-availability zone failover, and let's see if we can do this kind of in an animated way. So you have your master database instance that's in, say, availability zone 1. You are then going to automatically get a secondary standby that is synchronously replicated. So the writes are going to happen against both instances at the same time. Now, whenever you want to do any kind of maintenance or backup, what happens is AWS will automatically flip the DNS to the standby. So the standby becomes the master. And as a result, it then has the ability to update, backup, do any kind of maintenance against the now slave or standby instance. Now you're probably wondering, well, shouldn't it update and do all that before it fails over? Well, I mean, that's a given, right? So in the situation that it was in prior to failing over, to switching the DNS and failing over, that standby was available for all sorts of updates, backups, maintenance. It was the standby. But when you flip the DNS, you are assuming that that standby is up to date, and then that gives you the option of then updating, backing up, or maintaining the new standby, the previous master. And then when you're ready, it'll just fail over that DNS again, and it goes back to being, as a master and standby. Now, in the event of a read replica, the read replica is a little different. So what happens there is that could be in a different availability zone, and what you're doing there is asynchronous replication. Asynchronous replication means that the database is not necessarily in sync at the exact same time. There is a lag for the read replica to be in sync. However, it can help by offloading a lot of the read operations. So if you have the databases are typically read intensive applications. So read replicas will help by offloading some of that load and offloading it to read replicas. So you can have multiple read replicas. I'm going to show you in a second when we get into the management console how you can create these read replicas. But the idea here is to again distinguish between the fact that read replicas are asynchronously replicated from the master. So they're not happening, those writes are not happening at the exact same time. There's a lag, whereas synchronous is happening at the exact same time. Now, all of the maintenance, again, happens against the standby, not against the read replica. So let's take a look at some of the characteristics of the read replica. Read replicas are designed for workload shading and offloading. Again, because they are never going to be written to, they are designed to offload a lot of the read operations. So again, workload sharing. They are created from a snapshot off the master instance. So the way, when we go in, I'll show you in the management console, when you go in to create a replica, it is taken off of a snapshot from the master instance. It is also asynchronously replicated. It's a read-only connection. And it's only for read-only disaster recovery. Now, what does it mean, read-only disaster recovery? Well, in the event that the master, and let's just say also the standby, are experiencing a disaster. Maybe, I don't know, a natural disaster takes out both availability zone where they're both located. The read replica can still kind of service users, except it's only servicing them from a read operations, right? So they can only read. They're not going to be able to write to this database. You can promote some RDS database engines like Postgres, MariaDB, and MySQL from a read replica to a database instance. So with those particular database engines, you can do that. Now, the last thing that I want to talk about before we get into the demo are RDS reserved instances. Let's talk about some of that. So they've got certain characteristics. When you're buying that reserved instance, you're buying it against the database engine, you're buying it against the database instance class, you're doing it against the deployment type, against the licensing model, and against the region. If any of these attributes should change, if let's say you provision a new RDS instance where any of these attributes change, you cannot apply that RI to the newly provisioned RDS. What happens then is that newly provisioned RDS is on an hourly basis. If you modify any of these attributes on an RDS instance that already has an RI, it automatically reverts to an on-demand instance. If you later on deploy a new RDS that meets all of the originally configured RIs for RDS, like everything that you've originally configured here, that RI gets automatically applied. So it's important to understand when you configure the RDS reserved instance, all of these attributes will stay the same. You can move them, but you have to move them to an instance that has all of the same attributes. Any changes reverts to on-demand. If you make a change to an existing one, reverts to on-demand. If you deploy a new one with these same attributes, you can then automatically have that RI applied to it. Now, RDS reserved instances can be moved between availability zones in the same region. There's no problem there. They're available for multi-AZ deployment, so you can deploy them between availability zones. They can be applied to read replicas, provided that the database instance class and region are the same. Again, here the attributes will play a role.